In previous lecture, I already discussed some logical equivalence involving conjunction and disjunction like identity laws, domination laws, idempotent laws, double negation laws, commutative laws, associative laws, distributive, De Morgan laws, absorption laws, and negation law. In today's lecture, I will discuss some more logical equivalence involving conditional statement and biconditional statement. P implies Q is logical equivalence to negation P or Q. I already discussed this by using truth table. P implies Q will be false when P is true and Q is false. Now negation P. So in case of P true, negation P will be false. Now false or false, it will be false. So true implies false, it's false. In case of P implies Q and negation P or Q, negation P will be false as P is true, and false or false it will be false. And in rest case it will be true. Next, P implies Q is equivalent to negation Q implies negation P. It's the contrapositive. I already discussed that conditional statement and its contrapositive are equivalents. Next, P or Q is logical equivalence to negation P implies Q. Let me check it by truth table. P, Q, two propositional variables, so there will be 4 rows. True, true, false, false, then true, false, true, false. Now P or Q. P or Q will be false. If both are false, rest it is true. Next, negation P implies Q. Let me write negation P here. So false, false, true, true. Now negation P implies Q. So false implies true, it will be true. False implies false, true. True implies true, true. True implies false, it's false. Now check these two columns. It's true, 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 false. So P or Q is logical equivalence to negation P implies Q. Next, P and Q is logical equivalence to negation P implies negation Q. So we'll consider P as true, true, false, false. For Q, we'll take true, false, true, false. Now P and Q will be true when both P and Q are true, rest it will be false. Next, P implies negation Q. Let me write negation Q here, it will be false, true, false, true. Now P implies negation Q. True implies false, it will be false, rest it will be true. Now negation of this, it will be true, then false, false, false. You can check these two columns, both are same. Both have same truth value. So you can say P and Q is logical equivalence to negation of P implies negation Q. Next is negation of P implies Q is equivalent to P and negation Q. You can check this by truth table. Next is P implies Q and P implies R is equivalent to P implies Q and R. So we are taking Q and R and we are taking P as a common. P implies Q and R. Next, P implies R and Q implies R. So first P and Q are different, R is same. First part is different. We can write P or Q. Just mark, here it was and, now it's or. P or Q implies R. If first symbol is same, then simply P implies Q and R. So this logical operator will not change. If second symbol is same, like here R is same, then this logical operator will change. So P or Q implies R. Next, P implies Q or P implies R. Here first symbol is same, it's P. We can write P implies Q or R. This logical operator is not changing, it's same, it's or. P implies Q or R. Next, P implies R or Q implies R. Here second symbol is same, so this or will be and. P and Q implies R. You can prove all this by truth table. There are 3 propositional variables, so there will be 2 power 3, 8 rows. Next, logical equivalence involving biconditional statement. P double implication Q is logical equivalence to P implies Q and Q implies P. So P implies Q will be false when P is true and Q is false. And Q implies P will be false when Q is true and P is false. Now this is P implies Q, it will be false, here it will be true. Then Q implies P, in case of Q implies P, this will be true, this will be false. True implies false, it will be false. Now and of both, it will be false. In case of and, true will be true, rest it is false. So false and true, it will be false. True and false, it will be false. So both and will be false. In case of biconditional statement, if both are true or both are false, it will be true, rest it is false. Next, P double implication Q is negation P double implication negation Q. Let me check it by truth table. P, Q, P double implication Q, then negation P double implication negation Q. Now P true true, false false, Q will be true false, true false. Then P double implication Q, true true will be true, false false will be true, this middle two will be false. Now negation P and negation Q, negation P will be false false, true true, and negation Q will be false true false true. Now both double implication false double implication false, it will be true, then false double implication true, it will be false, true double implication false false, then true double implication true, it's true. Now check this to truth value, true false false true, so both are logically equivalent. Next, P double implication Q is logical equivalence to P and Q or negation P and negation Q. Now it's your homework, read the truth table for checking these two are logical equivalents. Next, negation P double implication Q is logical equivalence to P double implication negation Q. Here negation symbol was before bracket, here negation symbol is with Q. Let me check it. Now true, true, false, false, true, false, true, false. P double implication Q, it will be true, true, middle two will be false. Next negation of this, so it will be false, true, true, false. Just opposite of P biconditional Q. Now find negation of Q, it will be false, true, false, true, it's negation of Q. Next P biconditional negation of Q. True, false, it will be false, true, true, it will be true, false, false, it will be true, false, true, it will be false. Now check these two truth value, it's false, true, true, false. So both are logically equivalent. In next lecture, I will discuss how we can use this logical equivalence to prove that two compound propositions are logical equivalence without creating the truth table. Creation of truth table is time consuming, so it can save our time. We can directly use the basic logical equivalence to prove that two compound propositions are equivalent. If today's lecture is helpful for you, please like, share and subscribe. Thank you.